All right, guys. So today we're going to go over plate tectonics. So I'm going to go ahead and click present. If you would like to take notes as you follow along for extra credit, please do so and turn it into Google Classroom. But we are going to go over, let me go back one. We are going to go over plate tectonics today. And I'm sure you've heard of plate tectonics before. It's basically the theory that we live on top of plates, as you would call it, or jigsaw pieces that all fit together. So like the North American plate right here fits into the Eurasian plate and the African plate and so on and so forth. And we all sit on top of lava and move around. So let's go ahead and dive into this theory. This is going to be a bit of a longer note session, so just be prepared, but you can pause at any time and take a brain break. Okay, so plate tectonics. So the rock that forms Earth's surface, or the crust, is like a jigsaw puzzle. The pieces fit together, but each piece is separate, and you can see that on the right if you follow my pointer. Each of these white outlines shows a different plate or jigsaw piece. So movement of these pieces causes changes to positions, sizes, and shapes of Earth's continents and oceans. So this is the makeup, basically, of the surface of the Earth. Okay, so still on tectonic plates, recall. So we just learned about this in the last one. From the Earth's layers, the upper part of the mantle makes up the lithosphere. So this is the lithosphere right here, as you can see. The lithosphere is divided into giant, slow-moving chunks of rock called tectonic plates, and they're also known as lithospheric plates. So like this one would show you two plates being pushed together. You can even see on the top, they actually call it the North American plate. So those are what we're talking about. The lithosphere on top of the asthenosphere are where the plates are sitting. Okay. So a little bit more, tectonic plates float on thick liquid rock of the asthenosphere. So remember, this is still part of the mantle. This is the bottom part of the mantle. And the asthenosphere is heated by Earth's core. That's why it's liquid. And this heat causes the rock to melt into magma and expand. So I know this is kind of a difficult theory, but when we think of expansion, we think of something getting bigger. So if you like expand a balloon, the balloon's going to get bigger. So if we put the balloon under sand, right, and we blow up the balloon under the sand is going to it's going to create a lump on the top of it. So when we're talking about the magma, think of blowing up a balloon. So as the asthenosphere is heated, the heat causes the rock to melt into magma and expand. When this magma expands, it becomes less dense and rises. So we're getting higher, and that you can see right here as little bumps, if you follow my pointer, going into the lithosphere. So the asthenosphere is making the lithosphere rise. Okay, so as the heated magma gets closer to the surface, it starts cooling down. And the reason why it's cooling down is because it's getting further from the core. And remember, the core is very, very, very hot. So the further it gets away from the core, the cooler it's going to get. And when something cools down, it starts to sink. So we have this rising and sinking of the lithosphere and the asthenosphere, and this causes then a flow of movement. And this is where we get the theory that the tectonic plates are constantly moving. It's from this rising and falling of the asthenosphere and lithosphere. And again, you can see that on this picture. Forget about the numbers and everything, but just look at the fact that there are humps and there are tall parts and small parts of the asthenosphere and lithosphere, almost like waves. And that shows this rising and falling theory. Okay, so now we're going to talk about boundaries. Each of the tectonic plates, we talked about how they fit together like jigsaw pieces. Well, you know how when you're doing a puzzle, you still have different, ends and boundaries of the pieces that go together. And that's the same thing for tectonic plates. They each have different boundaries. And the boundaries are the areas where the edges of the plates meet. And not all the boundaries are the same, and each type of boundary is characterized by